So yep, minus the negative is definitely going to make that a plus. Now, I mean, if we'd started with this, I think that would have been a lot better, right?
Yeah.
But we have to see minus the negative stuff because we're dealing with the negatives. And so here, of course, 3 plus 5 is, okay, this one is going to be 8,
So it's
positive 8. 3.5 and 3.6 today, but here's 3.5. Our objectives, I can determine if answers will be positive or negative, which is pretty crucial when we're multiplying and dividing with integers, so negatives as well. And then, of course, we should be able to multiply or divide them. So is it positive or negative? Again, this is the first thing that I recommend students do while we get used to this positive, negative thing and multiplication and division specifically. It's kind of similar to what we do with addition and subtraction, where it's like, all right, especially if you have addition of opposite signs, and you look at which one is bigger, and then you say the sign of the answer will be that sign. But now, instead of seeing which one's bigger, we don't care about the largeness or the size of the negative or positive. We just want to know how many there are, and that will help us to determine if the answer actually is positive or negative. All right, when signs are the same, the answer is positive. Yeah, so we've seen a lot of this stuff already. We've done a lot of positives times positives, positives divided by positives, and then in the past we've seen that this will give us a positive answer. It's pretty nice. If we deal with positives, it's pretty basic, not really, I mean, we still got to do a lot of thinking, but just not necessarily on the sign part of things. But this is where we get into the negatives right here. So again, if the signs are the same, if they're negative and negative, and notice it doesn't matter which operation you're using, if you have two negatives, you have a positive answer. Bam. Okay, so that is the way that most students say it in the past, and yep, we've already heard it in this class too. Two negatives make a positive. Okay? And that's pretty good because for the most part, we're only going to be operating with two numbers at a time. And if we see that they're both negative, then we will make sure that the answer is a positive. Now, on the other hand, if there's only one negative, and that's the way I look at this. I don't really go in terms of like opposites. I say, how many are there? So here, they're opposites, which you can say then. That if that works, that's good. But I would say you got one negative will give you a negative answer. And it doesn't matter where the negative is. It can be in the first position or the second position. It can be your dividend or it can be your divisor. Either way, your answer will be a negative so long as you have one negative that you're operating with. And that's it. So that's going to help us to make these determinations. Can we just determine if an answer is positive or negative? Because if we can get past that, then we pretty much get to ignore the negatives altogether. And I think that's really good because, like I said before, we've already done a lot of positive operations. But if we can figure out if the answer is positive or negative, then we get to ignore any negatives. So on these examples, 1, 2, 3, 4, 5 examples, we're not going to solve these. I know you want to, but we're not going to. We just want to know if the answer is going to be positive or negative. That's it. So right here, this first one, now you can say that you have the same sign. You got a negative and a negative, which will make the answer a positive. Or you can say you got two negatives, which makes a positive as well, and that's good too. So this one will be positive. It doesn't really matter which way you say it on this one, whether you say you got one negative or they're opposite signs, positive and a negative. The answer for this next one definitely will be a negative. Okay? All right, now notice we're not even asking anything about the sizes of the numbers. I don't care that this is 16, which is bigger than 8. I don't care about that. I don't care that this is a really large number and this one's not as large, but it's still pretty large. I don't care how big the numbers are. All I care about are the signs of the values that we're operating with. That's all. So this next one, so two negatives. Again, however you want to say it, two negatives make a positive. They're the same signs. Either way, our answer will need to be positive. Now again, in doing this before we do these next few, the idea with this is once we know that the answer, the sign of the answer here, then it's just straight operation. So at this point, I would just do 2,100, and notice I just treat it like a positive. and then 9,771, and I would just multiply those two to get my answer. And then I know that that answer is positive, but I don't care about the signs of negative or positive after that. I don't care. So this next one, yep, so these ones have opposite signs, or you can say you have one negative, which will make the answer a negative. And then down here at the bottom, okay, now this is pretty common, like we've seen a lot of positive times positives in the past. And we just never focused on if the sign was, or the sign of the answer was going to be positive. Now we need to know, because we're going to be dealing with negatives, but you may still see some problems even on the assignment that are just like, hey, positive times a positive. And again, we're not going to solve. And so we're not, no need for simplification or anything like that. We just want to know what the answer will be, positive or negative. So this first one, yep, these ones are opposite signs. So this first one will be, oh, there it is, negative. The next one, I have a negative divided by a negative. Next up, we have a negative, and this is a fraction line, but it's still it's just a different way to show division. Negative divided by a negative, the answer is this one right here. The negative, if we see only one negative sign like this, it means one of these is negative and the other one has to be positive. But this does not mean that both are negative. It just means that only one of them is. So this one is going to be a negative answer. So this one with the negative sign right there, if we had written it as the two values being divided, what you can do, because it's showing only one negative, so if you want that one negative to apply to the 257, you can. And this is a negative divided by a positive, which will produce a negative answer. But if you really wanted to, you could say, well, I'm going to make the 9 a negative. You still have a positive divided by a negative, which will still give us a negative quotient. So it doesn't really matter which one you apply it to. But again, in this class, when we do get into the negative fractions, we'll only be applying it to usually the first number. Yep, this last one also with opposite signs, or there's only one negative, however you want to look at it. The answer is a negative. Now again, the best part about this is once you know the sign of the answer, then you get to ignore all the negatives and just do straight division, or like we did on the last slide, multiplication. So we saw the first part right there. Now we feel pretty comfortable knowing if an answer is positive or negative. After that, after we know if the answer is a positive or negative, then we can go straight into the operation. But like it says, we will be ignoring the negatives. Okay, so it's not showing the operation, which means it has to be, so since it's not showing, it has to be multiplication. This is 8 times negative 6. Now don't do it all at once. Break it down into parts, okay? So just like we saw in that last slide, let's first figure out if the answer will be positive or negative. So I've got a positive times a negative. There's only one negative, or you can say they're opposite signs, which will make my answer a negative. So there's my negative sign. After this, all I care about is 8 times 6. So I'm rewriting it this way, which you don't have to do, just to show that I don't really care about the signs anymore. I'm just looking at 8 times 6. I don't have to worry about the sign. I know the answer, the sign of the answer. And 8 times 6 is 48. Now again, the answer is not 48. The answer is negative 48, because we already knew that the answer has to be a negative. Okay, perform this indicated operation, which is just a different way to show multiplication right there. So yes, this one, just to identify, we have 2 negatives. 2 negatives make a positive, so I have a positive answer. So I don't know, I just do this positive sign right there, which I wouldn't type in to the computer, of course. But then, yeah, just 1 times 9 is 9. Really, that's all we want is the 9, because we don't need a positive sign to show that it is positive. But if it helps you, do it. Okay. All right, negative 7 times 9. So again, let's just figure out if the answer is positive or negative. So we definitely know it's going to be negative because there's only one negative in the answer. And then again, after that, it's just 7 times 9. Don't worry about your negatives, because we've taken care of the negatives, because we know the answer is negative. 7 times 9, boom, 63. So our final answer, negative 63. So the good news as of now, right? I mean, we're just multiplying some one-digit numbers. We don't really need to stack and multiply as long as we have the multiplication tables memorized. I mean, you could use addition if you need to, and that's okay as well. We still want you to memorize the multiplication table, but we haven't had a need for stacking and multiplying. This is great. So I like this problem, not just because I'm a math nerd. Well, it is mostly because I'm a math nerd. And it just, usually when I show this to students, it's like, what the crap? We were doing two numbers, and then suddenly we get this crap right here. What do we do with this? Try it. Just try it out, okay? I just feel like it's not as bad as it looks, and I'll explain why, but try it out. Okay. Well, I did count then. Well, I'm going to count again just for the video's sake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, just right there, I counted 11 negatives. All right, now, why am I doing that? It's because this is going to help me to determine the sign of the answer. That's it. All I want is the sign. And 11, as it turns out, is odd. And an odd number of negatives will produce a negative answer with multiplication and division. So it could have been 9 negatives, it could have been 7 or 13 or 21 negatives. As long as there's an odd number of negatives, my answer will always be a negative. Just like 1, right? 1 is considered odd, and so it will produce a negative answer also, okay? Well, that's the easy part. Now we got to do all this multiplication, right? No, we do not have to do all the multiplication. Exactly. The ones don't change anything, right? Anything times 1 is itself. In fact, I'm going to put that in here. Anything times 1 is itself. And the reason why that's important is because you can take 1 times 1 and it's still 1. You can take 1 times 3 and it's still 3. All these multiplied by 1s, I can just pretty much get rid of. Oh, I forgot that one. And this one, and these 4. Meaning that really all I'm looking at, I'll do this down here, is 3 times 10. Well, 3 times 10, I would really do 3 times 1, which is 3, and then tack on a 0. It's 30. Or you can memorize the multiplication fact there. Now, applying that to the negative, which we knew the answer was a negative, boom, that is all. So applying that to this one, again, if you were to look at this and say, well, I just want to do 2 negatives makes a positive. You could do that, right? You could say these 2 negatives makes a positive between these. Looks like we had one here, and here, and here, I guess, and I may have too many, or not enough. But again, you could have done that. You just could have looked at 2 at a time and said, well, 2 negatives makes a positive, and then eventually you would have had a negative in the end. It gives us another rule, which you don't have to memorize, of course, right? Because down here at the bottom, we say if there's an even number of negatives, the answer is a positive, which really just means that 2 negatives makes a positive, right? And then odd, I mean, you know, we shouldn't see more than maybe 5 numbers being multiplied at a time. But yeah, if there's an odd number of negatives, your answer will be a negative. So all of this right here is just meant to help us to figure out if our answer will be a positive or negative, and that's it. Okay, well, try this one out. -2 times 4 times -5. So on this one, we see, just to start out, let's figure out the sign of the answer. I've got 2 negatives. 2 is even, which makes my answer a positive. So again, you can put the sign there. You don't have to. After this, it's just straight multiplication. Now, to be honest, I would do 2 times 5 just because I know that's 10, and that makes multiplication a little bit easier. But even so, you can just do 2 times 4, which is 8, and then you'd still have multiplied by 5, which 8 times 5 is 40. So we end up with the answer that is positive 40. So on this one, just the answer, right? The answer will be since it has 3 negatives, 1, 2, 3, that's an odd number of negatives, so the answer is a negative. Or you could say that the 2 negatives become a positive, and then you're just left with a negative, either way. Now, operating from left to right, would have 3 times 5, which is 15. And then we would multiply the 15 by 2, so we'll have to stack and multiply that. 15 times 2. 2 times 5 is 10, carry the 1. 2 times 1 is 2, but add the 1 makes that 3. So we end up with 30. Now again, the answer is not 30. We already knew that the answer was going to be a negative. So it is a negative 30. Usually we feel pretty good after all that stuff, and we can figure out if answers are positive or negatives. This is where, just because of the format, the exponent format, that things get a little confusing for most students that do this. It says, what is the difference? What are the differences between these? So this is negative 2 to the power of 4. Is negative 2 to the power of 4. And I'm trying to emphasize it differently so it sounds different. Or you got negative 2 to the power of 4. So a lot of students, just because we don't have a lot of experience with exponents, they're like, they're all three the same. They're not the same. And it has to do specifically with the stuff we just went over, which is how many negatives are being multiplied. So this is almost strictly order of operations stuff, which sounds really weird. But if we go back to order of operations, you've got parentheses, which there are some, but there's nothing to do inside either set of parentheses here, okay? So it's not really a parentheses thing, but it is an exponent thing, right? Because in the order of operations, you would do exponents first. So if we said, well, you have to do exponents first, that means that this first one, let's just focus on this one right here. So that's negative 2 to the power of 4. Okay, that means that you would have to do 2 to the power of 4 first, which sounds kind of weird. But that means I've got 2 to the power of 4. That means I've got 4 2's all being multiplied together. 1, 2, 3, 4. Okay, that's, again, it's just a strictly order of operations thing. And then we would apply this negative on the outside. Now, you may ask, well, why is that the negative is kind of separate from the base 2? It's because it really would read negative 1 times 2 to the power of 4, okay? Now, that doesn't have to make sense. But what does have to make sense is that we know that in this expression right here, there's only one negative, which makes our answer a negative as well. So there's a negative. And then we can do the multiplication. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. Boom. Now we know this answer is negative 16. Okay, so this next one. Now we've got, it's in parentheses. The negative 2 is in parentheses. Notice on this one that we have the parentheses that is to the power of 4. Meaning that it's all the parentheses to the power of 4. And so we end up with this negative 2 in parentheses, which is to the power of 4. So I've got that negative 2 in parentheses, but I need 4 of them all multiplied together. There's 2, and then there's 4 of them. So now we would look at this, and just because of the parentheses specifically, we see that there are 1, 2, 3, 4 negatives. 4 is even, so this answer becomes a positive. And then again, 2 times 2 times 2 times 2 will be 16 again. But now this one's positive 16, which is the difference. Okay, so this one gave us a negative 16 answer. This one gives us a positive 16 answer, specifically because of how many negatives there are. So just between these two, if you do not see parentheses like this, there's only one negative. So the answer is a negative. Pretty much this negative is saying that the answer is a negative. But the negative being in parentheses like this one tells us, yeah, the exponent tells us that there are 4 negatives that are being multiplied. 4 is even, so the answer is a positive instead. On this last one, I would just, it's hard to say, look at this with the order of operations, because the only operation we're seeing is the exponent. But it is an order of operations thing, meaning the negative right there on the outside, I would like to show it as a negative 1. So we end up with negative 1 times 2. Now the 2 is in parentheses, right? Again, this exponent is only being applied to the parentheses. Maybe I shouldn't have shown the negative 1 yet. So the 4 is saying that there's 4 2's being multiplied together, not 4 negative 1's being multiplied together. So I would take that 2 and multiply it by itself 4 times. Now hopefully that's, a little bit more clear maybe. But now that we got all this multiplication, there's only one negative being multiplied, one is odd, so the answer is a negative. And then once again, 2 times 2 times 2 times 2 is 16, so we end up with an answer here again of negative 16. So this first one right here, the negative on the outside tells us, again, I'm putting it in red really to separate it from the 6 to the power of 2. So we have to look at this as 6 to the power of 2 first because of exponents. So that would be 6 times 6. And then the negative gets applied to it. And again, if you want to look at that as negative 1, that's okay. But with this now, you can see with the multiplication, there's only one negative. One is odd, so the answer is a negative. 1 times 6 is 6, times 6 is 36. So, negative 36.
Negative.
Yeah. Now, so this one is definitely going to be a negative. Get that in there. Now, the reason why I'm doing this is because I changed the exponent to a odd on purpose. Now, it will be a negative. So the next question that we should ask is how many negatives are being multiplied? So as long as we understand that there is only one negative being multiplied here, one is odd, which makes the answer a negative. Okay, well, how about this next one? Will the answer be odd? Sorry, that's not what I was meant. Anyways, let's ask the correct question. Is the answer going to be positive or a negative?
Negative.
Negative, correct. Okay, so now that we know it will be a negative, just to make sure we didn't get lucky, how many negatives are there going to be multiplied together here? And 3 negatives being multiplied together. 3 is odd, which makes our answer a negative. There you go. Multiplication and number lines. So the first factor will tell you, and it has to be this way on the assignment, I've checked. When I tried it the other way, it marked the problem wrong. So the first factor tells you how many groups or sets of the second factor there are. So the second factor that we're going to be looking at will be how long the skips are. The first one tells us how many skips there are, if you use the wording that's on the assignment. So if we were to look at an example, like let's say 5 groups of 2, okay? Now you could, of course, because of the commutative property, you could say 2 groups of 5. But this one, just the way that it's written on the assignment, you'd have to do 5 groups of 2. Now we know 5 groups of 2 is going to be 10, which is good. But on the assignment, what you'll have to do is you'll have to put a mark, if I remember right, at 0 first. And then you've got to give every 2 its own mark, but you've got to do 5 of them. So you do 1, 2, 3, 4, 5 of those marks. And you can't do this on the assignment, but if they could, they'd want you to do this. And I don't know why this makes math people so happy, but it does. Like if you were to show this to a math teacher, it would really make their day. Like they'd go home and tell their family about, like, look at this thing that I found. They'd post it on Twitter and social media and be like, this is amazing. So again, this is the way that it should look on the assignment. Start your model by placing a dot at 0. So like I said, you'll have to start at 0. Unfortunately, though, for this one, it's 5 times negative 2. So this number line, it's going in the wrong direction. So we're going to have to make it ourselves. So let's ignore the original. Sometimes the technology works. Let's see. It was giving me troubles. Oh, well. That was my fault. Okay, well, I'll take it. Let's give ourselves some markings then. We need to go, well, let's see how far we can get. So 1, 2, 3, 4. I'll do every 5 marks just because I'm actually that lazy. Negative 6, 7, 8, 9, 10. So we're in the negative still. I think I can fit 11 on there. And that'll do it for us, okay? So this one is 5 times negative 2, which would be, in actuality, 5 groups of negative 2, like this. So this one is a little different from the last slide that we saw because they were both positive, so let's skip forward to the right. But again, you would have to start at 0. So you got to, it says you got to put a dot at 0 just to start out with. So there's my dot at 0. But now the skips have to go in the negative direction because it's groups of -2. Now, once again, you can't just say, well, I'm going to put a dot at -5 and then put a dot at -10. If you do that, it will mark you wrong on the assignment. It doesn't mean your answer is incorrect. It just means that you've not done exactly what they want, which is unfortunate. But 5 groups of -2 means that for every 2 marks, I need to put a point. So that'd be -2, -4, that's -2, -4, -6. There's my 4th mark at -8, and then my final mark at -10. Boom. 5 times -2 is -10. Now again, I'm not a huge fan of this number line stuff, because for me it's easier to be like, well, there's only one negative, my answer, 1 is odd. So my answer is a negative, and then 5 times 2 is 10, boom. All right, so here's division. So we've seen this already. We just may see the division in different ways, right? So just straight division, you got your dividend and divisor. When we looked at this with fractions, you got numerator and denominator. Really, this is a fraction right here. And it's important to remember when we do long division, which we may need to do, that it's the dividend that goes inside the divide symbol right there. And then we can long divide, which we will do. So yeah, dividend divided by divisor, dividend, divisor, and then your answer is a quotient. Yeah, we'll be using long division. We've seen this slide already. Now that we're doing this with negatives, of course, though, we just need to really know how many negatives there are, or like we've seen already, if you prefer to look at it like if 2 negatives makes a positive or 1 negative will make the answer negative, it's really up to you. Okay, so what is the division problem asking? It's not asking us to solve, apparently. The answer would be 4, though. This one is asking how many 9s are in 36? And again, there's 4. If we think about this, how many 9s are in 36? And the answer is 4, of course. But another way to put it is 9 times something is 36. And of course, that would be 4. So how many 9s are in 36? There's 4 of them. And, you know, you could model this and say, well, I got 36 of something. There we go, 36 something circles. It could be dollars, it could be degrees or whatever. And no, I'm not going to count all those, but there is 36. And would say, how many groups of 9 are there? So, well, let's see if we can make this happen with some technology. Okay, so if I were to say, well, look at this group of 9. There's one group of 9. There's another group of 9. There's another group of 9. And there's another group of 9. 4 groups of 9 in 36. So that's why they're, how many 9s are in 36? That's what this is asking. That's why the answer is 4. So this one, so that was a positive divided by a positive. But now we got a positive divided by a negative. So the answer will be a... Correct. Yep. Now again, after we figure out the sign of the answer, which is a negative, because there's only one negative, 20 divided by 4, boom, 5. So our answer is -5. This is just another slide. It's, I don't know, I wouldn't say it's a nerdy way to explain what we've been doing, but it's kind of the same stuff that we have been doing. With division, pretty much we should not be dividing more than 2 values ever at a time. So if we see, like we do on these ones, if you have 2 negatives, your answer will be a positive. If you only have 1 negative, in either one of these cases, either as a dividend or divisor, or numerator or denominator, your answer will be a negative. Or, like we've seen before, sometimes what they'll do is, it doesn't matter where the numbers are, but they'll put the negative out here, which again tells us there's only 1 negative, which is odd. So our answer will be a negative as well. Okay, so we will divide this on this one, but let's again first, let's just determine if the answer is positive or negative. A negative times a negative is a positive, or you can say there's 2 negatives, which is even, so the answer will be a positive. That's good enough. Now we will do the division. So this is 574 divided by 7. All right, so The 7 will not go into the 5, but it will make 57. We'll go into 57. I got 8 times. 8 times 7 is 56. So when I subtract, that leaves me with 110 left over. And then I'll drop the 4 to make it a 14. Oh, that's nice. Because 7 will go into 14 exactly 2 times. 2 times 7 is 14. So we used up everything, and our remainder is 0. The quotient there is 82. And again, we know it's positive 82 because we already figured out the sign. But once again, it's nice to have all the negatives taken away from our long division. Not that it makes long division nice, but it makes so we don't have to worry about the negative stuff anymore. Division with 0, so dividend versus divisor. Again, the dividend it says if it's the first one, like it is here, as long as 0 is the first number being divided, your answer will be a 0. If it's the second number that's being divided, it's really the same thing as asking how much of nothing is in something, and there's a whole lot of nothing in something. In fact, there's an infinite amount of nothing in something, which is why we say it's undefined. So this is a rule that we need to have memorized because usually there's problems like this on exams as well. These two right here. Now it's set up a little bit different, but you could rewrite it if you'd like to. The first one would be 0 divided by negative 36. It's exactly the same, but the 0 is first or it's on the top, which makes the answer here a 0. So the second one, again, if you wanted to rewrite this one, you'd have negative 72 divided by 0. It's exactly the same. But this one, with 0 being on the bottom, it would be undefined, which we can just write as D and E does not exist. Changing division to multiplication, we just use these fact families. Of course, there's other methods to use, and if you have those methods, which is just principles of equality, you can use them. But for now, we'll change any division into multiplication or multiplication to division. You can even change division problems into other division problems like this. So again, if we had like 12 divided by 4 equals 3, you could change that into 12 divided by 3 is 4 as part of this. This is what we call a fact family, which we've seen already. And then if you needed the multiplication, notice that the 12 is the dividend, the two divisors, 4 and 3, or the divisor and the quotient become the two factors of the multiplication problem. So rewrite the division as multiplication and solve. Actually, we could just solve this as it is, but we will rewrite it as multiplication too. And it may help to have the quotient on this as well. So let's just start with that, even though we're kind of going off track here and we're not following their directions, which is okay. But I see a negative divided by a negative, which makes the answer a. Very good. So the answer will be a positive something. And then we would look at 54 divided by 6, which is 9. So we end up with a positive 9. Okay, so that's our division problem. Now you could change it into a new division problem as the negative 54 divided by, we'll put a blank, but we know the blank is 9, and then it would equal the negative 6. And then you could even see that a negative divided by a positive will give you a negative answer, or one negative will give you, which is odd, will give you a negative answer. But what they do want is the multiplication problem. So the blank, which I put in purple and we know is 9, you would take the 9, or the blank, and then you could multiply it by, it's always the second number in the division problem, which is showing as the negative 6, and then that would equal, should equal negative 54. Now, if you think about this too, especially since we know the answer is 9, which I will fill in now, if you did these backwards, right? If you accidentally did like 9 times negative 54 equals negative 6, hopefully you would know, no, that doesn't make any sense. 9 times negative 54 would definitely be a lot more than negative 6. So if you switch these up, hopefully it would be obvious by writing the problem out. But again, take your time on those so that you don't make that mistake. So we did solve. We got 9, and we've written the multiplication problem too. There we go. So there's 3.5, multiplying and dividing. But yes, we will always figure out if the answer is positive or negative first with multiplication or division, and then we do the actual operation.